We're surrounded by smart devices, right? Our phones, watches, cars, even our homes. They make life so much easier, but let's be honest, there's a big trade-off we're all making for that convenience: our privacy. Every little piece of data these gadgets collect is a potential weak spot. So how do we get all the amazing benefits of AI without building a world that's constantly watching us? Well, let's dive in and figure that out.
This quote just hits the nail on the head, doesn't it? The very thing that makes our technology so intelligent is also what makes it a prime target. That is the razor's edge we're all living on, and that's exactly what we're going to explore today. And look, this isn't some abstract, far-off idea. We are talking about a global price tag of $10.5 trillion every single year. That's an almost unimaginable amount of money. This stuff is happening right now, all around us.
So here's our game plan. We'll kick things off by looking at just how vulnerable our smart world has become. Then we'll unpack why the old way of handling data is totally broken. From there, we'll get into the exciting stuff, a revolutionary new way to train AI. We'll check out the clever tools that keep it all secure. And finally, we'll dream a little about the smarter, safer future this could all lead to.
The whole Internet of Things thing has just completely exploded. It's not just our phones and laptops anymore. We're talking about our light bulbs, our refrigerators, our cars, even the basic infrastructure of our cities. And every single one of those new connections is like a brand new door for an attacker to try and bust open. 75 billion. Just let that number sink in for a second. To put that in perspective, that's nearly 10 smart devices for every single man, woman, and child on the entire planet. And each one is a tiny data collector, creating this massive, tangled web of potential security holes. And it's not always some super sophisticated Hollywood-style hack. A lot of the time, it's just a clever trick. This right here is a classic phishing attack. You get an email, it looks legit, you click a link, and it takes you to a fake website. You type in your username and password, and bam! Just like that, the attacker has the keys to your digital life.
Now, this is where things get genuinely scary. Our own devices can be turned into weapons and used against us. In what's called a DDoS attack, a hacker can hijack thousands of ordinary smart devices, your security camera, your smart speaker, and use their combined power to flood a website or an online service with so much traffic that it just collapses. The very tools we rely on every day can be used to shut down the services we need.
So, you might be asking, how in the world did we get to this point? Well, it turns out that a huge part of the problem is the very architecture we've been using to build our AI systems. For years, we've been centralizing everything. And folks, that model is on the verge of breaking.
Okay, so here's the old school way of doing things. To make an AI smarter, the idea was to just suck up everybody's data and ship it all off to some giant central server in the cloud. But that creates a massive dilemma. It becomes a giant, juicy target for hackers, it costs a fortune in bandwidth to move all that data around, and honestly, it's a legal minefield with all the new privacy laws popping up.
Just look at this diagram. You've got every single device sending its raw, personal, sensitive data to one single spot. In the security world, this is what we call a single point of failure. It's like putting all of your most valuable eggs in one basket. If that one server gets breached, everyone's data is exposed. It's a total disaster just waiting to happen.
But what if we could just flip this entire model on its head? What if we could train powerful AI without ever needing to see the raw data in the first place? Well, that is the incredible promise of a truly revolutionary idea called federated learning.
This is the core idea, and it's so beautifully simple, it's kind of genius. Instead of forcing all of our private data to travel to a central AI model, we bring the model to our data. Your personal information never, ever has to leave your device.
So here's the basic rundown. A central server sends out a copy of the AI model to a whole bunch of individual devices, like your phone. Each phone then uses its own local, private data to train and improve that model just a little bit. And here's the magic part. The only thing that gets sent back to the server is the updated model, just the lessons it learned, not your personal data.
Now, this isn't just a one-and-done thing. It's this carefully choreographed dance called a training round. It involves a multi-step process between the server and all the devices. So let's break down exactly how one of these rounds actually works. All right, here's the play-by-play. First, a bunch of devices that are ready for training check in with the server. That's step 1. Step 2, the server sends out the current version of the AI model to all those selected devices. Then, for step 3, each device does its training locally and reports back only the updates.
And finally, step 4, the server intelligently combines all those little individual updates to create a new, smarter global model. And this cycle just repeats over and over, with the AI getting smarter with every single round.
So just sending the model updates instead of the raw data is already a massive win for privacy. But what if we could make it even more secure? That's where a really powerful set of cryptographic tools comes into play. You could call this the secret sauce.
First up, we have something called homomorphic encryption, and honestly, it's basically like magic for data. Imagine you have two numbers, but each one is locked inside its own separate, unbreakable box. Homomorphic encryption lets you add those two numbers together without ever needing the keys to open the boxes. You just get a new, slightly bigger box, and when you finally unlock it, the correct answer is inside. It means the server can combine all the model updates without ever being able to peek at what's inside them.
And it's not just one type of magic either. You've got different tools for different jobs. Some, like this one called Palier, are awesome for just adding things up, which is perfect for securely summing all those model updates. But others, like CKKS, are way more powerful and can handle complex math, which allows for some really sophisticated AI training, all while the data stays completely encrypted and locked down.
Next on the list is something called Secure Multi-Party Computation, or SMPC. The best way to think about it is like this. Imagine a group of friends want to figure out the average of their salaries, but nobody wants to tell anyone else how much they make. SMPC is the set of techniques that lets them all work together to find out the average without a single person ever having to reveal their own private number. It's collaboration without exposure.
And just like with encryption, SMPC has a few different flavors. Some methods work by splitting a secret into a bunch of little pieces, so no one person has the whole key. Others are built for speed and are super efficient for adding things up securely. And some even have a built-in cheat detector, making sure no one is trying to sneak in bad data to mess up the results. It's all about building a system you can trust, even when you can't see what the other players are doing.
Okay, so we've seen the huge problem of our vulnerable smart world. And we've seen this really elegant solution. But now let's zoom out. What does this all actually mean for the real world? What does a future that's built on privacy-preserving AI actually look like?
Well, this tech opens up a whole new world of possibilities, especially in really sensitive areas. Imagine hospitals all over the world collaborating to build better cancer detection models without ever sharing a single piece of patient data. Or your phone's keyboard getting way better at predicting what you're going to type next without your private texts ever leaving your device. Cars could learn from each other's near misses to prevent accidents, and farms could share insights to grow more food, all while keeping their own proprietary data completely safe.
And the really cool part is this isn't some rigid, one-size-fits-all solution. The whole system is incredibly flexible. You could have a simple setup where devices talk directly to a cloud server, or you could have a much more complex system with local edge servers that gather results from a region before passing them on. It's all about finding that perfect balance between speed, scale, and privacy for whatever job you're trying to do.
You know, we started this with a really big problem. The smarter our world gets, the more vulnerable it seems to become. But federated learning gives us a way out of that trap. It's a blueprint for a future where we can have amazing, collaborative intelligence without creating a world of constant surveillance. So, I guess the real question to leave you with is this. Now that we have the tools to teach our devices without them spying on us, what incredible things will we empower them to achieve next?